This is the Viking. It's our dedicated 6x6 uncrewed ground vehicle, or UGV. Designed over a number of years, and what we have here is the latest iteration of our Viking platform. Used by a number of NATO allies. In fact, we've just announced a contract. We're going to award 8, we're going to supply 8 to Italy. This is a very sophisticated, highly capable, dedicated uncrewed ground vehicle. So designed to fit inside CH-47, you can fit 2. It's 6-wheel drive, 4-wheel steer, which means it's highly mobile, okay, highly capable. Unlike similar sized UGVs that have tracks or fixed wheel systems, this is able to operate over quite complex terrain. It's got a very high degree of mobility, and it also will look after whatever's on the payload because of the suspension that it has, okay? So if you have a delicate payload like a casualty or a very expensive piece of equipment or sensitive piece of equipment, it's well looked after by the platform. Okay, so it's a series hybrid. That means it can operate in EV mode only. So in EV mode only, capable of up to 30 kilometers distance. That means it has a very low noise and thermal signature, which is great in terms of keeping the asset hidden. Yeah. It then also has a separate engine, which is able to charge the batteries and power the vehicle, and that will give you another 250 kilometers minimum of range. But obviously, depending on the mission, the vehicle may be stationary for long periods of time, and that onboard power generation means that you can charge the batteries and continue to power the payload. Okay, so we use our own computational hardware. So underneath the hood, you've got state-of-the-art computational hardware that allows us to do a lot of edge processing, and we use a lot of AI and machine learning. So that means this vehicle can operate off-grid. There's a lot of processing in terms of the perception sensors that you see on the front of the vehicle. So on the front of the vehicle and on the rear of the vehicle, we have 2 sensor hoops. They have a combination of passive and active sensors. We prefer to use passive. Our autonomy capability is built on the fact that we want to use passive wherever we can, for obvious reasons. We have stereo vision camera, we have day and night cameras, thermal imaging, and then we do use a LiDAR. And we use a LiDAR when we have to, but we prefer to use passive systems if possible. The platform has a variety of modes, so you can use it in remote control, teleoperation over longer distances beyond line of sight. We'll use radio, 5G or satellite communications, or fiber optic for fixed line. And the vehicle has a number of autonomy modes. So it'll either follow you or follow a vehicle, which is great when you want to go into a particular location and you want the vehicle to carry equipment for you, or also have an operational mode where it'll go from point A to point B. You give it a plan, a mission, the vehicle will navigate itself, modify its route based on what obstacles it finds, okay? So conventional autonomous capability. There's nothing without the payload. And here we have a counter-UAS mission system, combination of an I-STAR and a Leonardo remote weapon system. But this vehicle can be supplied with either a basic logistics payload, so carry water, food, ammunition, casualty evacuation, or more sophisticated missions like counter-UAS, anti-armor, like we'll show you in a minute, CBRN, I-STAR applications as well. Okay, it's quite flexible, and we use our AI capabilities to really enhance the payload, the mission. So, for example, using the I-STAR solution we have on the platform, we can use our AI to help identify targets, recognize the target, and confirm whether it's a threat or not. Okay. If we move over to this vehicle here, you'll see another version of the Viking. And this time, it's configured in a battlefield anti-armor configuration. So that means it has its own missile launcher with 3 missiles in this particular setup. Typically, these will be a precision strike, surface to surface or surface to air, capable of maybe up to 10 kilometers. We can work with a range of different lethality providers. We've partnered here with MBDA. And this gives this vehicle a sort of a shoot and run, a shoot and scoot capability. So the vehicle can hide, the vehicle can wait to be engaged or triggered by passing vehicles. It then can autonomously move into the right location, fire its missiles, and then disappear. This has been proven to have a very lethal effect against main battle tanks, and is a really an interesting configuration for, let's say, Nordics and Eastern Europe. Behind me to my right, we have our vehicle that we call CL2X. So whilst the Viking platform is designed to operate alongside soldiers, operate alongside wheeled vehicles, this is really designed to operate alongside main battle tank or heavier tracked armored vehicles. So this is a much heavier platform, circa 16 ton. It'll carry a payload up to about 5 ton. Here we have a Leonardo turret, and this platform is really configured to work alongside a main battle tank in a wingman scenario. It can either be controlled from within the main battle tank or from a third location elsewhere. Obviously, we can fit it with different turrets and different payloads. And wherever we can, whilst this is a dedicated UGV designed from scratch with IDV, we have taken into consideration now how can we keep the cost down, keep the serviceability very high. So for instance, we're using some M113 running gear wherever possible, because that's highly available and highly configurable. Okay, so these are the 3 UGVs we have on our standard IDV. And I'll just show you in here what we have on our digital display. Going to come in. So against this back wall here, we are simulating what we have with a typical scenario of an operator operating many UGVs.